All right. Good morning, good afternoon, good evening, everyone. Welcome to Q4 update to what's next in OpenShift, where we give you a glimpse into the product roadmap, direction, initiatives, and exciting new use cases and features that we're going to address over next 16 to 18 months. This is an hour-long presentation that covers the summary and motivation of the roadmap. Specific details for each topic cover and more can be found in the appendix section for offline access. Please note that the material discussed here is subject to change. My name is Shreyans Munkutkar, and I have a terrific team of OpenShift product managers who will join me as speakers. Let's get started. Today, we have four key trends driving the industry. First, the push for application and infrastructure modernization. Driven by market factors in the virtualization space and existing infrastructure, organizations are looking for flexibility and want to avoid vendor lock-in. Next, AI. Users want a powerful platform where they can use their data for effective model training. Next, organizations want a development environment that is easy to use and reliable, with built-in security for their entire process of building, deploying, and running software. And finally, you want to do all of this next to your data, whether that is in cloud, on-prem, across various geos. When you look at these drivers from AI to sovereignty, it becomes clear that software applications are now absolute core of every competitive enterprise. However, organizations face several challenges that prevent them from adapting to new technologies and delivering experiences to their clients. Let's see what those challenges are. Some of these challenges have been with us for some time, such as application modernization and developer productivity. 95% of IT decision makers still believe that app modernization is essential for their organization's success. Then, there are a few challenges that are new or rapidly increasing, particularly driven by the acceleration of AI. Everyone around us is now using AI to create content or develop tools. Gartner predicts that 80% enterprises will have developed generative AI enabled applications by 2026. The rapid growth of AI is creating two major problems. Number one, it requires developers to learn new skills pretty quickly, and two, it introduces newer security risks. To overcome these challenges, you need an application platform that allows you to innovate at speed, adapt to rapidly growing market conditions, and deliver newer experiences for your clients. That platform is Red Hat OpenShift for you. OpenShift gives you an unified application platform for all your workloads, from containers, VMs, to AI workloads. The platform is trusted in a way that the software supply chain use is reliable and secure, not just for the platform, but for your applications as well. It is comprehensive, that it encompasses all aspects of your software development. And it is consistent whether you're running in cloud, on premise, or at the edge. The success of this unified approach is precisely why OpenShift continues to be recognized as an industry leader. For the third time in a row, Red Hat OpenShift is recognized as a leader in the 2025 Gartner Magic Quadrant for Container Management. Similarly, Red Hat OpenShift is also recognized as a leader in 2025 Gartner Magic Quadrant for Application Platforms. Now let's switch our focus on what are the focus areas for the CY 2026 year and beyond. So as we approach the upcoming year, we'll be focusing on five key areas. First, we are accelerating the use of AI. This includes enabling AI workloads to run efficiently on the core platform and empowering you with all the necessary tools to build more intelligent applications with OpenShift AI. Next, we will accelerate developer productivity by simplifying and automating the entire build to deploy process. while unifying general purpose workloads, VMs, and AI all on a single platform with OpenShift virtualization. Next, security is paramount to everything that we do. We are continuously building better security into every step of the platform and the application process. And we are adding new features to protect your software supply chain. We will continue to advance our multi-cluster management and governance capabilities. This evolution is designed to help you scale and manage workloads across data centers, public clouds, and at the edge. Additionally, you can reduce the operational overhead with OpenShift cloud services, whether you want to run in AWS, Azure, Google Cloud, or the IBM Cloud. And finally, with intelligent OpenShift, we are injecting AI into OpenShift to deliver enhanced productivity and customer satisfaction. Before we jump into every section, just a small note. You'll see the use of terminology near, mid, and long-term presented in every section. This roughly translates to 6, 9, and 12 months timeline respectively. Let's jump into a few key spotlight features. Number 1, intelligent OpenShift. The future of OpenShift is intelligent, and our vision is to infuse AI throughout the OpenShift ecosystem and the operational lifecycle to dramatically boost your productivity and operational efficiency. This makes OpenShift portfolio more accessible to both technical and less technical users. At the heart of this transformation is OpenShift Lightspeed, our generative AI virtual assistants. We enable more use cases and transform how you operate and interact with OpenShift through natural language prompts and agents that will let you get insights, streamline your upgrade experience, troubleshoot, debug, get more risk analysis, right-size your clusters, and many more such use cases. This is made possible by leveraging an MCP gateway and MCP server at the core of it. We have already introduced MCP servers as dev preview to help you query your cluster and help with incident detection. The MCP gateway prioritizes security, enforcing authentication, authorization, central control, and guardrails to reduce unsafe behavior. The next spotlight feature is security. OpenShift is significantly advancing its zero trust and secure by design posture over the next year by hardening every layer of the platform, from workload identity to data protection to supply chain integrity. We are expanding protection of data in use through confidential computing, ensuring that even the platform itself can't access certain sensitive workloads. Our new Zero Trust Workload Entity Manager brings strong workload-bound identities for secure service-to-service communication. To prepare customers for emerging risks, we are introducing quantum-safe cryptography. We are extending the Zero Trust to virtualization with vulnerability reporting for VMs provided by our ACS offering, and we are strengthening governance with automated drip detection. We are layering in AI-driven risk analysis to evaluate behavior and context per user. Together, these capabilities make OpenShift a platform engineered for zero trust, from protecting your workloads, identities, data, and the entire software supply chain by design. Next, Peter will walk us through exciting updates on OpenShift virtualization.
Thank you, Shreyans. It's been an incredibly busy year in the virtualization team. If you saw the IBM update back in Q2, the revenue we saw was probably about 300 million, and it's been growing like gangbusters. As part of the virtualization migration assessment we do with customers and partners, Red Hat themselves have looked at over 1.1 million virtual machine workloads to migrate into OpenShift. Now scale that across our regional and global system integrators and partners, and it turns into a very large number. A lot of the work that we're focused on for 2026 is based on direct customer feedback. We prioritize based on things that focus on ease of adoption, scalability, and configurations and capabilities that they don't have today with virtual machines on OpenShift. And this includes different platforms as well. So let's dive into some of the highlights. As far as migration, ease of migration, we have cross-cluster migration, which will allow you to move workloads non-disruptively across clusters in your environment. That will let you do lifecycle management, resource balancing, or just general maintenance without disrupting any of your user workloads. We also have storage offload that is part of the migration toolkit for virtualization. This is an ability to leverage the capabilities inside of a SAN storage array that increases the performance of these migrations significantly. We've had partners reporting 10x or higher. So for moving things like large databases, you're going to get an incredibly fast rate. As far as simplification for management, we are leveraging advanced cluster management with a fleet virtualization view that allows you to see VMs across your entire enterprise. And you can not only use it for observability, but also using actions on VMs anywhere they are in your infrastructure. We've also improved the user experience on initial deployment, especially around, we'll be working on making network configuration easier and simpler for the workloads that you're looking for. Storage and data protection, we have a lot of things teed up here that are underway. Incremental backup with change block tracking at the virtualization level. We have partnered with every one of our data protection partners in the ecosystem. They are looking at this as soon as it's available. We've got dev previews that are going to them as we speak, and we'll make that capability available as soon as we can across all of the data protection partners. The last one that's also very exciting is disaster recovery for VM workloads from site to site recovery. We want to be able to leverage native storage replication that exists across many of the enterprise storage partners that you use today and be able to recover quickly workloads in case of a huge disaster. Let's talk about, networking. There's a lot of changes networking in OpenShift itself, and we want to make sure that VMs can leverage user-defined networking easily. There's a lot of work going on in terms of BGP, making sure that all of your OpenShift clusters and the workloads can integrate directly into your data center fabric. And then we're looking at adding EVPN and VMs leveraging that so you can actually stretch your network across clusters so it looks like a single network and you can seamlessly move workloads. As I said earlier, that cross-cluster live migration would be able to use a capability like this. As far as the core virtualization platform, we have some very platform-specific things we're looking to change in terms of business continuance, making sure that you can restart a VM very quickly. Today, we're approximately in the 90-second range after a host failure to restart a workload. We want to be able to get that down under a minute or even lower. We've also been able to use live migration for VGP workloads. This allows you to non-disruptively move a GPU accelerated workload from one host to another. That gives you a lot more flexibility in terms of managing your operations. The footprints where you can run virtual machines on OpenShift is actually expanded greatly. If you were paying attention or looked at the 420 what's new, we've got networking enhancements that are coming for AWS and GCP, making sure that we can attach and use the advanced capabilities for that networking, and then be able to move workloads from the ground into the cloud or across clouds. Lastly, security. We want, as Shreyan's mentioned earlier, ACS will be able to scan your virtual machine workloads. And there's a documentation for deploying hardened OpenShift virtualization clusters. This will improve your security profile. And then lastly, We've been also focused on the performance of large database workloads like SQL Server, Oracle, and Postgres. So we want to make sure that the virtual machines and workloads that you bring over from your existing platform run as fast as they do today. In summary, we can handle lots of different interesting footprints, large workloads, and use them in a flexible way, whether you run them on-prem, in the public cloud, or on the edge. Now let's hand it off to Mac to talk about some of the core platform improvements.
Amazing, thanks, Peter. So yeah, let me share now what areas are we going to focus on next for core OpenShift. Next slide, please. So we think that great technology should let you focus on what matters. That's the principle behind our install experience. We are not here to tell you where to run OpenShift, but we are here to give you the freedom to choose and make that choice effortless. So what's coming? Let me share what we'll be focusing on. Dedicated and specialized infrastructure across every major cloud, hybrid and edge deployment that extend your reach. Advanced platform features that bring enterprise-grade capabilities wherever you run OpenShift. On the network side, modern architecture with dual stack support deployments, private and secure networking that truly isolates your workloads, encryption and key management that puts you in control. And for our customers in government and regulated environments, sovereign clouds, compliance-ready regions, everything you need to deploy OpenShift on these regulated environments. Next slide, please. Our focus on OpenShift virtualization lifecycle management in these connected environments is simplicity and robustness. We are committed to providing simplified day one and day two air-gap cluster management without the need of an external registry. This makes initial setup and ongoing operations much easier in highly secure disconnected environments. In the short to mid-term, this translates into two key operational enhancements. For day one operations, we are introducing an install experience with a user interface to make air-gap cluster installations straightforward. For day two operations, you will gain the ability to easily upgrade your OpenShift cluster and add new nodes, all within the air-gap setup. The ISO that we are working on at the moment will provide Arcos, OpenShift, and pre-selected day two operators. Looking at our long-term plan, we aim to extend the platform reach by delivering multi-architecture support. Additionally, we will provide ISOs to support a wider array of specialized use cases beyond the standard cluster deployment model. Next slide, please. Hosted control planes transform how we think about Kubernetes, both economically and for operational simplicity. We are continually to invest heavily in this form factor for OpenShift. Our top priorities for 2026 are the general availability of ARO hosted control planes, one of our managed OpenShift offerings, Azure hosted control planes for self-managed customers, and ROSA hosted control planes by default on new clusters, and also support non-bare metal environments like vSphere, Nutanix, and others. In doing this, we are introducing features to enable these top priorities that will enhance hosted control plane support on all platforms, without, as said, losing the focus on the 2026 plan priorities for hosted control planes. So you can see a summary here of some of these features that will come in the next months. Next slide, please. We continue to invest for control plane, specifically invest on optimizing OpenShift for large clusters, adding support to configure the event TTL in etcd, and the size of the etc database, allowing a more efficient etcd cluster, especially in large OpenShift deployments, as I mentioned before. We will add support for automated etcd backups as well. On the security side for control plane, we will add support to configure the key size of the RSC key, and we are developing support for the Cube key management service, making it enterprise ready. And we will ship support for multiple providers, including HashiCorp Vault, AWS, and Sales. For OpenShift Auth, in the near term, we are enhancing bring your own authentication with complete structure configurations and tighten platform security. In the midterm, we are adding support for multiple identity providers, PKCE integration, and seamless authentication across clusters and applications as just one unified experience. And for the long term, we will enable conditional authorization for fine-grained access control and hardened security standards by default. So we are introducing dual OS streams, enabling Arcos 9 and 10 to run side by side in the same cluster. This extends specifically the life cycles for RHEL certified hardware and decouples the Arcos major version upgrade from OpenShift upgrades, giving you more control and reducing risk. We are also developing a tested confidential Arcos for trusted execution environments on cloud providers. And finally, we will continue to streamline image mode for simple installation and deployment workflows. For platform updates, we are focused on making OpenShift update experience faster, safer, and less disruptive with minimal operation overhead. We are planning to introduce maintenance windows to give you more control over when updates take place. We want to ensure smoother updates, and we are working to reduce the false alarms that occur during pre-checks and during updates. We are also working to add support for N2N+3 updates with a single worker reboot, letting you remain in an older US version even longer. Lastly, to encourage more frequent updates, we are planning to introduce skip level updates which leverage an emulation to do so. This makes updates safer while also opening the door in the future for rollback. Storage is foundational to everything you build. We are making it more flexible, more reliable, and more cost-effective. We will be adding broader infrastructure support across vSphere and Azure, cloud-native snapshots, and cloning for faster recovery. We will also work on live performance tuning without downtime, enhance backup capabilities with chance block tracing, and volume group snapshots. And we are solving the Linux relabeling issues that have impacted some of you. All this plus intelligent cleanup tools to help you to identify and use storage and reduce the cost. So basically, better data protection with lower cost. With our AI workloads effort, we are aiming to set the stage for future of efficient workload management. First, we will deliver local queue defaulting and multi-queue capabilities to streamline the developer experience, supported by full observability integrations. Next, we plan to enable ACM and autoscaler integrations for automated scaling alongside dynamic resource allocation for better handle complex job sets and AI training. And finally, we will implement fair share cohorts and intelligent queuing. This will guarantee that your critical workloads take precedence while maximizing cluster utilization. And that's all for the core. Now over to Aaron.
Thank you, Marcos. And speaking to you from Red Hat Cloud Services, yes, this is Aaron. Next slide, please. Across the big three clouds, you will see managed OpenShift focus on roughly 5 themes in the coming quarter. and into 2026. The themes are security posture, architecture refinement, observability, virtualization, and of course, artificial intelligence. Next slide, please. Here I will cover all of our exciting new features planned for our managed OpenShift services across the 3 major clouds. Let's start with Red Hat OpenShift Service on AWS, or better referred to as ROSA. The first one is enabling Windows license included and bring your own license options for virtualized workloads. These allow customers to unify Windows, VMs, and containers on a single platform while optimizing costs in tune with existing AWS licensing patterns. Next, we'll see control plane log forwarding and enhanced monitoring. These features enable cluster admins to forward logs to preferred systems and receive better alerts, thereby significantly improving cluster observability. Next up, efficiency with AutoNode, sometimes known as Carpenter, and Spot instances. Utilizing Carpenter for faster auto-scaling and Spot instances for suitable workloads allows for better performance while reducing compute spend. Longer term, we plan to implement both Scale 2 from 0 to maximize resource efficiency and BGP network support to enhance networking for virtualization workloads. Now on to Azure Red Hat OpenShift. First, let's talk about confidential containers moving to general availability. This provides vital isolation for workloads in highly regulated industries that need an enhanced security posture. Jumbo frame support. This means higher MTU values for more efficient network usage, which is a key requirement for network-intensive applications. Region expansion continues into Mexico Central, New Zealand North, Indonesia Central, and Malaysia West, ensuring customers can deploy workloads closer to users for lower latency and data sovereignty. Finally, hosted control planes. By offloading the control plane infrastructure to Red Hat and Microsoft, we can offer customers significant cost savings and increased reliability. And now for OpenShift Dedicated. First one is OpenShift Virtualization support, allowing you to unify all workloads, both VMs and containers, onto a single platform to simplify management. Next is integration with Google Managed Prometheus. This provides a centralized cloud-native monitoring solution, allowing you to use Google Cloud tools to monitor your OpenShift workloads. Next, we're tightening security by reducing the permissions in both the workload identity federation and shared VPC features. This is aligned with our focus on security with our customers. Finally, for the long term, we are targeting hosted control planes architecture and Spot instances to bring those same benefits of cost savings and operational efficiency to our Google Cloud Platform customers. Now I will hand it over to Ramon to talk about workloads and layered offerings.
Thank you, Aaron. Next slide, please. So hello, everyone. Workloads and layer offerings are at the foundation of what makes OpenShift an enterprise application platform and can be structured on 3 layers. At the bottom, we have a content governance model to simplify the management of your clusters. On top of that, we provide application lifecycle management tools to streamline application delivery. And finally, at the very top, we have architectural transition tools to help you on your journey to cloud-native application development. Let's talk about the roadmap for these offerings now. Next slide, please. There you go. So for OpenShift Console, in the short term, our focus is on modernizing our core technology by updating both the OpenShift Console and the dynamic plugin framework to the latest major versions of React and React Router. We will also continue the technology preview of Operator Lifecycle Manager V1, introducing a complete user experience for the creation flow and the management of V1 installed operators. Our longer-term goal is to achieve the GA for OLM V1 and significantly improve the cluster upgrade process once we integrate the enhanced operator upgrade experience. This is aligned with the roadmap for the operator framework, which revolves around the GA of OLM v1, with focus on improving the user experience for cluster upgrades by providing more accurate and reliable status information for cluster operators, and also providing consistent TLS configuration to all OpenShift components. Finally, for Quay, in the short term, our focus is on scale and security by delivering organization mirroring and supporting massive scale content distribution, and also hardening our foundation by replatforming onto UV9 minimal and running with a least privilege configuration by default. In the long term, focus will shift to efficiency by introducing sparse manifest lists to ensure devices only download the specific architecture they need, and also by delivering the next-gen registry, which is our slim Go-based registry designed with single-node OpenShift in mind. For builds, in the short term, we will add support for running shipwright image builds in user namespaces in order to increase isolation of build containers and add an additional layer of security to image builds. And also, we'll be providing assistance to customers migrating from legacy build configs into shipwright builds with a new migration guide and enhancing the migration toolkit for applications to support this migration path. Future improvements include dependency catching to improve build times and multi-arc builds. For pipelines, the tech preview for multi-cluster support will arrive in the near term, enabling pipeline runs to execute on adjacent clusters when the current one doesn't have enough resources. Also in tech preview, we will enhance Tecton results to improve artifact traceability in the software supply chain. We will integrate with OpenShift Lightspeed, first for troubleshooting of failed executions, and then for assisted pipeline authoring in the longer term. Finally, for GitOps, OpenShift GitOps will soon be available for customers to try out in Developer Sandbox. In the short term, we're also looking at widening our signing and verification capabilities with source verification policies. And also the Argo CD CLI is moving towards GA. And we're also working on an Argo debugging integration with OpenShift Lightspeed. Further out, we are progressing multiple tech preview features to GA, like progressive sync, image updater, and application sets in any namespace. For the migration toolkit for applications, in the short term, centralized configuration management will enable organizations to manage their fleet of MTA ID plugins and enforce migration standards. Aligned with that, we will start providing support for developer Lightspeed for MTA on dev spaces. In the longer term, migration toolkit for containers is expected to sunset in 2026, and MTA will assume its use cases during several releases spread throughout the year. We will be expanding developer Lightspeed for MTA with an MCP server for integration and providing AI assistance for rules generation. For service mesh, short-term includes initial support for post-quantum cryptographic algorithms and adding multi-cluster support for ambient node. To improve workload attestation with service mesh, we will introduce an integration with Red Hat's Zero Trust Workload Identity Manager based on Spire. Looking further out, we will improve our current integration with Red Hat's Advanced Cluster Management and add additional integration with Kiali MCP Server and OpenShift Lightspeed for data analysis. And finally, for serverless, first, we are adding support for Keta-based autoscaling for functions and enhancing the HTTP add-on for Keta to enable HTTP autoscaling for Keta-based workloads. We're also adding a new user experience in OpenShift Console to enhance serverless function creation, management, and operation experience for developers. We will create a migration tooling and guides that will migrate AWS Lambda workloads onto OpenShift. And additionally, we want to enable developers to leverage serverless for AI use cases, starting with using serverless functions as an MCP server. Now, let me hand it over to Mark Schmidt to discuss networking. Thank you.
Thanks, Ramon. Usually we present the near-term list in no particular order, but for this update, there is a major priority being placed on EVPN, as this feature is critical for virtual machine migration, as well as wider BGP adoption. Along with EVPN, we'll have the BGP no overlay capability, which removes east-west traffic encapsulation, allowing for greater throughput. Other near-term priorities include intra-cluster vRouter, IPv6 single dual stack support for public clouds when the hyperscalers are ready, preparing for post-quantum cryptography and egress IP feature modernization. In the midterm, we're looking at taking EVPN and no overlay to GA status, SRv6, VPC, and QoS support, multi-cluster user-defined networking and networking observability, secure DPU support, and we'll have an OpenShift networking training offering. Longer term, we're looking at DRA net NRI integration with the caveat that Multis is not going anywhere anytime soon. We'll also have layer 7 traffic firewall filtering, applied AI for observability and troubleshooting, MCP gateway, looking to take that to general availability, and we'll continue to drive migrations from OpenShift SDN to OpenK, as well as driving 3-scale to Red Hat Connectivity Link migration. Additional Connectivity Link items in the planning process include developer portal for Developer Hub, MCP gateway integration, looking to take core DNS support to general availability, and automated DNS failover across clusters. For network observability, we'll have the network observability operator included by default on day 0 with the IPI and UPI, as well as an opt-in capability with the assisted installer. Other near-term work will include BGP observability, improved visualization of HTTP traffic, and a network health and alerting view in console. Longer term, we're looking to integrate gateway API metrics and enhance egress IP and EVPN observability as well. And with that, I'll hand it to Eric.
Awesome. Thank you, Mark. Next slide. Now let's take a look at the core focus area for Red Hat's observability strategy in 2026. Our strategy is built around 2 key pillars. First, we're heavily invested in AI-driven observability. The main goal here is straightforward: dramatically reduce the mean time to detect and the mean time to resolve incidents. And as a result, we're integrating AI-driven observability troubleshooting capabilities with OpenShift Lightspeed. We're expanding observability for the next generation of computing, specifically by focusing on GPU and accelerator metrics and capabilities for Gen AI workloads alongside key partner integrations. And a key focus is standardizing OTel data. This is crucial for giving our AI models the high-quality data format they need to work more effectively. The second major focus is multi-cluster capabilities. As our customers scale, they need to easily manage and observe tens or even hundreds of clusters. Our plan to deliver this includes enhancing intelligent ACM with features like right-sizing recommendations for namespaces, VMs, advanced incident detection, and more. Next, we're building a truly unified and centralized observability experience through multi-cluster observability add-ons. We're also committed to a solid multi-cluster alerting experience, which involves enhancements to our alert management UI. And finally, we're integrating Percies to provide customizable dashboards directly within the ACM console. Now let's walk through our strategy for enhancing observability with AI. This is about making our systems smarter and giving our users better tools to understand and troubleshoot complex issues. In the near term, we have one key investment area. A major feature here is the AI Trace Summarizer. Imagine looking at a complex Gantt chart for a trace. This tool will use natural language processing to automatically generate a concise summary of that trace, displaying it right on top of the chart. Now that's a huge time saver for diagnosis. Moving into the midterm, we're concentrating on improving our current in-cluster troubleshooting by leveraging MCP servers, focusing on both single and multi-cluster enhancements. This is about making the flow from detection to resolution as seamless as possible. Looking further out into the long term, our goal is to enrich the data that we have. We'll be integrating OpenTelemetry and Tempo. This will give our users much richer context around all their observability signals, such as logs, metrics, and traces, all tied together for a complete picture. Now let's move to what's happening with multi-cluster observability in the very near future, where we're focusing on bringing immediate value in 2 key areas. First, for multi-cluster observability, we're introducing a technology preview of Percies integration within ACM. It's a new open source cloud-native project for visualization, and it will really help our customers manage their environments better. This means rolling out native and custom dashboards for both single and multi-cluster observability powered by Perses. We want our users to have intuitive and yet powerful ways to visualize their data. Second, we're moving a major workload efficiency feature to GA. ACM right-sizing recommendations. This will give our users concrete, data-driven recommendations to optimize resources at the cluster, namespace, and even the virtual machine level. This is a huge win for cost savings. Moving to the midterm strategy, where we're going to build on the foundation we just laid. The first point here is taking the Perses integration to GA. This means our customers will have access to both native and custom dashboards for a fully featured multi-cluster observability experience right inside of ACM. We're also planning post-GA enhancement for our right-sizing feature focused on continuously improving the quality, the accuracy, and usability of those recommendations across the cluster, namespace, and VM levels. Finally, our long-term vision is about making multi-cluster operations as seamless as possible, where we're looking at technology preview for an improved multi-cluster alert management UI experience, making it easier to see, filter, and act on alerts across all our customers' managed clusters. And a crucial piece of this will be the introduction of the incident detection capabilities, also the technology preview, giving our users the ability to proactively identify and address issues that span multiple clusters. All right, from a foundational perspective, in the near term, we're working on an optional lightweight monitoring solution. This is all about reducing the operational footprint, especially for smaller or edge clusters, while still giving our customers the essential data they need. Next, we're implementing Prometheus Remote Write version 2 support. Now, this may sound a bit technical, but the benefit is simple. It makes exporting our metrics more reliable and much more efficient. Furthermore, for the near term, we're introducing dedicated APM dashboards. These dashboards will specifically showcase red metrics, that's request, error, and duration derived directly from our distributed tracing data. This gives our customer a standardized, high-level view of service performance. Moving to the midterm, our focus shifts to clarity and coverage, where we're working on improved metric profiles. The goal here is simple: cut down on signal noise. We want to ensure the metrics we collect are the most actionable and relevant ones, leading to clearer insights. We're also looking at enhanced KSM metric coverage. KSM is vital for seeing the state of our customer Kubernetes objects. So we want to make sure that we have robust metric coverage there. And finally, going into our long-term strategy, the first critical step is ensuring the cluster logging operator and the cluster observability operator are seamlessly integrated and communicated effectively. This foundational work is essential for delivering a unified and seamless observability experience to our customers. The object is to tightly connect logs and metrics, eliminating the need for users to constantly switch between tools. And now I'd like to hand it over to Matthew, who will be covering the developer experience.
Thank you, Eric. Next slide, please. Let's start with Developer Hub. We're looking at three main themes. First, the core experience. In the near term, we're focused on flexibility, specifically customizable home pages, more localization, and a multi-login screen. So the portal can be more easily tailored to your specific organization and your users. Second, the plugin ecosystem. We're making dynamic plugins the default standard and removing the old system of wrappers. This under-the-hood change is going to make changing and updating your plugins significantly easier and remove a lot of friction we see today. And finally, AI. The big headline here is bringing developer Lightspeed to GA. We are also laying the groundwork for deeper AI integration with the Llama stack, moving towards more advanced use cases like AI notebooks in the long term. It's an exciting time for Developer Hub as we move from basic adoption to deep customization. Onto dev spaces. In terms of core features, we'll soon have support for nested containers, which will enable native Podman run capabilities, as well as new SSH to local to remote extension that will simplify configuration steps for IDEs through SSH. On the longer term, we also plan to create a no-code dev file editor, as well as a new plugin for starting workspaces directly from RHDH and Backstage. As some dev spaces and deployments are starting to hit thousands of developers, scalability is becoming even more important. With that in mind, we will soon support spreading developer workspaces across multiple clusters and a new way to back up and restore workspaces to keep work in progress safe. We're also excited to announce that in the next release, we're going to be adding Cursor and Kiro through Remote SSH as 2 new IDEs, as well as RStudio in the longer term. With that, let's look at what's in store for Podman Desktop on the next slide. In the near term, our focus is heavily on enterprise readiness. We are introducing automatic certificate syncing into the Podman machine, which will make it working on corporate networks much easier. We're also adding managed configuration so that you can configure Podman Desktop in one go for all your team, like adding a default container registry or a pre-configured proxy. Looking further out, we are looking to fully support Podman 6 and introducing a RHEL-based Podman machine. We're also focusing on migration workflows, specifically tooling to help you move from Compose to Kubernetes. Finally, we're looking at a deeper integration with Quay. Think of Red Hat Trusted Artifact Signer as your enterprise signing authority. It's built on SigStore and lets you cryptography sign and verify every artifact in your software pipeline. This gives you complete integrity and non-repudiation across your entire supply chain. We've recently added some really cool tech preview features. There's the model transparency library for signing AI models, and the model validation operator that makes sure only trusted AI models can run in your OpenShift namespaces. We also rolled out fine-grained high availability controls so that your SigStore service never goes down. Coming up, we're taking all of these features to GA. Our spring release will bring PostgreSQL's backend support, FIPS compliance, and the ability to deploy on AWS EKS. Later this year, we're focusing on something pretty groundbreaking, post-quantum cryptography. We'll enable signing container images with post-quantum digital signatures right in Red Hat's build pipelines, and we'll support deployment on RHEL 10. So whether you're securing traditional workloads or preparing for the post-quantum future, our HTAS has you covered. The secure supply chain component in the Red Hat Advanced Developer Suite makes it easier to set up a secure development environment. It comes with ready-to-use templates in Developer Hub that let you build safer CI/CD pipelines. Basically, it bakes security right into your development process, which makes your software artifacts haven't been tampered with, and helps meet your important security standards like supply chain levels for software artifacts, also known as SLSA. In 2026, we're aiming for full alignment between RHADS and Conflux, Red Hat's internal build system. Trusted Profile Analyzer has several new features incoming, including AI bomb component labeling, as well as the ability to generate SBOMs directly from Quay, and inventory-wide license searching. And finally, RHDA. AI model consumption is on the rise, and with the changing landscape of AI-powered IDEs, RHDA is evolving to help developers know more about the safety aspects of the LLMs. Just like we show CVE and remediation information for vulnerable packages, after highlighting the shortcomings of the AI models, we'll show practical guardrails and example code snippets to implement those guardrails within the project. The RHDA plugin is now also fully compatible with Cursor. With that, I'm going to hand it off to Anjali, and we'll take a look at security.
Thank you so much, Matthew. Very excited to present the security updates. Next slide, please. So security across containers, virtual machines, and AI workloads remains very complex. Advanced cluster security in 2026 will help teams enforce policies, gain visibility, and prioritize risk with AI-driven insights. Starting with policy and guardrails, which form the foundation. In the near term, Splunk integration will surface policy violations clearly. Drift prevention and policies as code will automate enforcement and reduce drift. Next, alignment with ACM and ServiceNow will simplify policy management. Over time, Developer Hub workflows and shared authentication across OCP, ACS, and ACM will speed remediation. Runtime visibility will improve detection and response. starting with file activity monitoring, which will help teams spot issues early. Next, process baselining will reduce manual tuning. Later, a runtime console plugin will bring detection and response directly into OpenShift. These changes help teams act faster with clearer runtime signals. Now let's look at vulnerability management, which will become even more actionable. Base image separation will clarify platform and application ownership. The console plugin will provide direct vulnerability visibility. CISA Kev enrichment will focus attention on exploited threats. SBOM imports and rel image mode will enable easier and earlier risk assessments. AI-based CVE prioritization will deliver explainable results, and zStream guidance will help keep OpenShift core images secure. We look to extend protection even to virtual machines. Linux VM vulnerability reporting will mirror container insights. Virtualization compliance profiles and zero trust workload identity will strengthen enforcement. And finally, Windows VM reporting will help complete the VM security posture. We also plan to scale compliance across multiple clusters. As mentioned, OCP virtualization compliance profiles will support consistent enforcements for VMs. Tailored scheduling and multi-cluster remediation will reduce manual effort and help teams stay compliant across multiple clusters. AI-driven security will further strengthen protection. Explainable risk prioritization will focus on high-impact threats. MCP-assisted insights will add more security context. AI workload discovery and AI bomb ingestion will help identify AI workloads, and later AI bomb scanning will assess risk and guide remediation. Lightspeed insights, artifact signature validation, and AI runtime detection will all help improve protection for AI native workloads. Now, together, all of these different capabilities will help our customers secure containers, virtual machines, and AI workloads with clarity and with confidence. Next slide, please. Now let's look at some of the built-in capabilities that will be coming with OpenShift security platform itself. So OpenShift delivers built-in zero trust security across your cloud-native workloads, helping teams reduce risk and simplify compliance. Let's look at how we plan to continue to deliver on features that will help our customers further hone security in 2026. OpenShift will continue to improve isolation with our confidential computing solutions. In the near term, confidential containers on Arrow and confidential nodes on AWS will protect sensitive workloads. We will expand support to bare metal and Azure for secure multi-tenant environments. Later, confidential containers for NVIDIA GPUs and confidential clusters on AWS and GCP will secure AI workloads across multiple environments. OpenShift is preparing for future threats with quantum-safe cryptography. First, we will add quantum-safe key encapsulation to the control plane, then to the OpenShift core. Next, we will support service mesh and gateway API. And finally, we will deliver MLKEM to protect the full platform. We will also extend MLDSA support for our OpenShift core as part of our future enhancements in this area. OpenShift will also continue its investment in certificate management. Trust bundle distribution and policy-based approvals will help enforce secure standards and automate certificate management. Gateway API and ACME support will further simplify certificate and encryption lifecycles. Our secret management solution will also continue to evolve. In the near term, external secrets operator enhancements will strengthen rotation and access control. Later, sync secrets, better secret rotation, and a unified secret console will centralize operations. These features will help reduce misconfiguration risk and improve the day-to-day for the secrets management. OpenShift also continues to expand on its zero trust workload identity offering. The Zero Trust Workload Identity Manager enables MFA for workloads, and provides runtime attested identities to all your workloads. In 2026, it will also support containers and virtual machines with OpenShift virtualization integration. It will also integrate with Service Mesh, ACM, Edge, and Trusted Supply Chain, providing zero trust identities to all your environments. Together, all of these capabilities in OpenShift makes it a secure and accountable platform for running all your cloud native workloads, whether they be containers, virtual machines, or AI. Thank you, and over to Luis for ACM updates.
Thank you, Anjali. Hi, everybody. My name is Louis, and let's talk about the future of multi-cluster management with Red Hat Advanced Cluster Management. First up, we've got virtualization. We've already delivered a lot of functionality for virtual machine admins in ACM, and we are doing even more in the next few releases. We're talking about a brand new and secure virtualization experience, which is specifically designed for the unique needs of virtualization admins to support the flexibility they need to manage the entire fleet of VMs. You want to move a VM to a better cluster? Great. Coming soon, you will be able to live migrate your virtual machines across clusters and save some resources. Next, in governance, we're making crafting and creating policies even easier with the lint option. It's a command in the policy tools CLI. This will help you identify syntax errors early in your policy development, preventing the policies from being deployed to clusters in your CI pipeline. For policy templating, currently there is a limited set of functions enabled for policy templating. We're looking to change our approach and enable them all by default, only excluding the ones that are not secure, of course. And next, on the long term, we've got custom governance dashboards. We know that dashboards offers great value in ACM. So this is about defining your own set of parameters and configurations to build your own dashboards for your governance policies, so you can organize them in the ways that work best for you. Lastly, we've got a deeper integration with validating admission policies, VAP. It's a stable API since Kubernetes 1.30. We're looking to provide dry run capabilities for VAP and improve the audit reporting of them to make it easy to understand the impact of your VAPs before you actually deploy them to your clusters. Finally, we've got IAM, Identity and Access Management. Imagine a integrated and centralized IAM solution that works for all of your industry standard offerings for authentication. Building on the work that we have delivered for virtualization, we're extending access control to cover so much more. We're planning to enhance security for how you manage both your workloads and your hubs. You will be able to set controls on things like pods, logs, dashboards, from view-only permissions to full control. Applications. Well, nobody does anything without applications, right? We are again committed to make it easier to deploy apps from ACM with a deeper Argo CD integration. Using the agent architecture, GitOps deployments will consume less processing power on the hub, bringing great benefits to deployments at scale. For observability, we will continue to bring powerful observability tools directly into the ACM UI. Right sizing gives you real-time feedback to better utilize your resources. If a virtual machine uses too much CPU or memory, or maybe a namespace is underutilized, Rackham tracks the numbers and provides the details via an easy-to-read dashboard. Down the track, we'll add the tools to leverage all the observability data collected by the hub. This will help you quickly size your environments, optimize namespace resource consumption, utilize Red Hat Lightspeed on premises, and benefit from other integrations with standard tools like Thanos and Persis. Speaking of Lightspeed, for AI and more, great plans are coming. We know that managing AI workloads across the fleet is becoming simple and more familiar, right? We're adding out-of-the-box stronger integration with OpenShift Lightspeed. Just simply ask Lightspeed fleet level questions and find what you need with pretty much natural language conversation. We are really talking about an easily deploy of batch jobs, building powerful GPU as a service offerings, or even connecting your agentic AI tool to chat directly with your fleet. Thanks for letting us share our upcoming features for multi-cluster management. We're looking forward to releasing them. Now I'll pass it over to Frank for Telco and Edge.
Red Hat Device Edge is our solution optimized for small form factor, field deploy services, leveraging RHEL and image mode. Our current priority here is a new Red Hat Edge Manager, which delivers comprehensive capabilities for managing edge device fleets. As we move this from tech preview to GA in the near term, we plan to extend it with advanced features, starting with predictive planning. Turning to Microshift, which adds Kubernetes capabilities on top of Red Hat Device Edge, we plan to add, in the near term, SRIOV capabilities, which helps with network function use cases and bring the generic device plugin to GA. This plugin simplifies access to sensors like cameras and serial ports, for instance. In the long term, we are looking into implementing cluster-to-cluster communication over a layer 3 network. Finally, OpenShift Edge. We recently announced GA for 2-node OpenShift with Arbiter. We will soon support the addition of worker node to this architecture. Parallel to this, we are engineering a true 2-node solution based on fencing technology. This is currently in tech preview, and we are actively seeking for design partners to test this. So please reach out if you are interested in contributing. Looking at our long-term strategy, we are focused on reducing bandwidth requirement for installation and updates. And we are also targeting topology transition, specifically enabling day 2 operation that allow you to switch seamlessly from single node to multi-node OpenShift. We continue to apply an upstream first approach to ensure durable innovation, and we invite your feedback and contribution as part of that process. We are investigating how to execute directly on OpenShift nodes capabilities that reside today in the data center fabric or in dedicated routing appliances. Concretely, this involves implementing VXLAN or SRv6 EVPN type functionality in software as part of the Linux host stack and transparently to the Kubernetes networking stack. In parallel, we are collaborating with the Kubernetes community on a new model for fine-grained resource allocation covering CPU, memory, and other resources, built on the emerging dynamic resource allocation framework, initially designed for GPU. This will help supporting more granular and therefore more efficient resource allocation to pod. Red Hat OpenShift cluster requires 3 control plane nodes to ensure high availability. However, the control plane itself does not need massive CPU capacity. With current server generation offering up to 512 CPU per machine, dedicating 3 full servers to the control plane is no longer practical. This is why we are adapting proven OpenShift features to meet telco requirements, so we can include them in our telco reference design solution. Depending on your security and operational requirement, you will be able to choose between a schedulable control plane, where workloads are co-located with the control plane, a hosted control plane, or a virtual control plane, where the control plane runs on a dedicated infrastructure, OpenShift cluster, either deployed as pod, either as virtual machine, respectively. On the hardware support side, for RAM, the next critical timeline is the introduction of Intel Granite Rapids D system, comprising of CPU, VRAM boost, and integrated NIC, with commercial hardware available by Q1 2026. Red Hat is working closely with Intel and third parties on a set of milestones to fully support this hardware. On the 5G core side, Intel Clearwater Forest delivers CPU densities up to 288 cores per servers. For ARM-based CPU, our intent is to continue our work on the NVIDIA hardware for telco edge use case combined with AI. The focus is on NVIDIA Grace Hopper and the next generation Grace Blackwell, as well as the next NVIDIA ARM CPU, Vera. We are continuously listening to the market and will monitor any requirement for non-NVIDIA ARM in the context of 5G core and multi-node OpenShift. Finally, for AMD-based CPU, we will be working on Venice support, which bring up to 1,000 CPU per server. Continuing our investment in image-based technology, we are enabling dual-stack networking across install, upgrade, and break-fix workflows. We are also addressing critical regulatory compliance and disaster recovery needs. Specifically, we are enabling the complete reconfiguration of a single OpenShift node networking stack post-deployment. Imagine a scenario where a national 5G network fails and infrastructure must fall back to legacy LTE or satellite links. The switch can be implemented by dynamically updating the address family, IP, or VLAN. The same capability can be applied to solutions related to temporary increasing the capacity in a specific venue by adding new VDU instances. It can also be used to rehome a VDU from one site to another or simply adjust for changing network infrastructure. All of these features will be available in the near term. Thank you, and back to you, Shreya.
Thank you everyone for joining today, and thanks to all the presenters for walking us through the roadmap for the upcoming year. The What's New and the What's Next sessions are published and publicly available at the first link highlighted here. Feel free to check out these new features at learn.openshift.com or try.openshift.com. Thank you again, and we look forward to seeing some of you at the Red Hat Summit in Atlanta, Georgia in May 2026. Have a wonderful day.